What's up? Welcome back to Advent of Code 2015, Day 8. Let's jump in. Matchsticks. Space on the sleigh is limited this year, and so Santa will be bringing his list as a digital copy. He needs to know how much space it will take when stored. It is common in many programming languages to provide a way to escape special characters and strings. For example, these languages handle special characters in a very similar way. However, it is important to realize the difference between the number of characters in the code representation of the string literal and the number of characters in the in-memory string itself. For example, quote quote is 2 characters of code, 2 double quotes. But the string contains 0 characters. ABC is 5 but contains 3 characters. This thing is 10 characters, but the string itself contains 6A and a single escaped quote character for a total of 7. So we have 1, 2, 3, 4, 5, 6, 7. And this thing here is 6 characters of code, but the string itself contains just 1 apostrophe, but escaped using hexadecimal notation. Santa's list is a file that contains many double-quoted string literals, 1 in each line. The only escape sequences used are backslash, which represents a single backslash, backslash double quote, which represents a lone double quote character, and backslash x plus 2 hexadecimal characters, which represents a single character with that ASCII code. Okay. Disregarding the white space in the file, what is the number of characters of code for the string literals minus the number of characters in memory for the values of the strings in total for the entire file? So for our examples, we have 23 characters and 11 values that we would store in memory. So let's copy the example. Then we can read each line. For each line, we can say number of chars is line.size or length, line.length, and then number of, so now we have different cases, right? So first we have to go through the string, which is the line is the string, for each character in the string. And what we can do is count the ones that we want. Result is 0. And then based on the character, we have to see what we want to do. For example, if it's a backslash, oops, no, if it's a quote, sorry. The quote, we just want to do nothing basically. I think it's a backslash, we want to go we need to count 2. What we could do is add a second counter and just say, hey, I see something and I need to add 2. But we don't know yet, actually. We don't know what the next one is. We need to come up with something here. What I can do is look at the next character. So if it's, well, first of all, what can happen is can be a slash. So if it's a slash, I want to look at the next character. This also didn't work already. Let's see if I have issues with that. But for now, I wonder what happens. Actually, let's delete everything and just print each character. And then I can print like something like this. I don't know why this one has an issue here. Okay. I wonder what it actually has as a value for this. The character should be a backslash, but maybe it's just a escape thingy. Okay. So if I go back to what I had, I needed this or not, not sure. Interesting, let's see if we find some of those or not. Yeah, we do find them like that. Okay. So if it's one backslash, then this character is this thing in Kotlin notation here. Okay, so we can find it, and then we can say for each indexed, we check line at index +1. The backslash is at index, and the next one is index +1. And we want to know what's going on there. When this one is X, we have the special case, right? We would, so I'm gonna introduce another counter. This will also be R. We need to count for characters. My screen is having some issues here. Anyway, let's see if it's another. What is the other ones? We have backslash, /sting or /x. Okay, so then we have another backslash. Actually, I've set C to 3, C to 1 here, and if the next one is a quote, C is 1, and I don't know why I can't change it. Okay, I am overloading the same variable name, offset or something. Somehow it's some kind of offset. Offset. So now we get some offsets here. Okay, so we don't want to do anything here. We want to set an offset if we see this. And then at the end, we want to start counting. If offset is greater than 0, then I just reduce the offset. And I think I always want to count. No, I don't want to count. I Only if the offset is 0 I count. So if I have nothing, then I offset is 1. Interesting. Do I want to do that? I don't know, because what if the previous one was a backslash and then I have this scenario? So if this happens, I have offset at 1. And then I keep offset as 1. Because what I want to do is I want to walk through and say if this is a quote, I don't want to count it. But if this is a backslash, well, what I can do is I always count the backslash and then I stop counting the next one. So if it's a quote, I skip it, and if it's a quote, I skip it anyway. Count a backslash. No, I have another issue now. If I always count the backslash, I would double count this one. So I can't do that either. What would be a simpler way? Or I just add another last one was backslash equals false. So if not last one was backslash, I skip it. And obviously here last one was backslash is true. And then I reset it. And then else is like if I have any other thing, I also have, I'm currently not a backslash. If I then have some offset, then I just reduce the offset, and otherwise I start counting. Okay, what happens then if I get the first backslash? Well, let's go through the whole thing. I get a quote. Last one is not backslash, so I just set offset to 1. Then I go here, and my offset is greater than 1, so I just reduce the offset, okay. Then I get another quote. So I go here, last one was not backslash, offset is 1, I just reduce the offset, I don't count, so the counter is 0. Number of, or whatever it was, memory size or something, is now R. That should work. Let's see, I can just run it as well. Then we have number of chars 2, memory size 0, 5, 3, is that correct? 5, 3, 10, 7, 10, 7, 6, 1, 6, 1, 10, 7. That's one that I made up myself. Let's go through it. This should be 1, 2, 3, 4, 5, 6, 7. That works fine. Why? Yeah, I go through. Let's go through the last one. As an example. And first I go here. Offset is 1, then I reduce the offset and don't count. Then I have A, which is else. So I just go to else. Reset. Last one was backslash true. False. And I just count here. I go to else. And I count again, and I have backslash. So here, backslash, I set it to true. Add some offset for depending on what the next line is, which is this one. So I set offset to 1, reduce the offset, get another backslash, set last backslash to true. Which is technically maybe not what I want. This is the second backslash, but let's see. Set the offset to 1 again. No, now I check the next 100 line, which is not a backslash. Okay, one thing that won't work is this. This should be 8 now, but it's 7. Because I just keep being in this loop. I just can't have... I just have to do not last one as backslash. I think, because if it's true already, I want it to be false again. Doesn't work still. The problem is I have a backslash, then I set it to true at the offset. Okay, wait, I can now say if the last one is actually a backslash, then I set the offset. Otherwise I don't want to set the offset because then I'm in the resolving phase. So I set this one too. I find the first one. Last one backslash is true. The reverse of false. It's true. I set the offset. I don't count. I reduce the offset. I go to the second one. I set it to false, the opposite of true. This is now false. I don't set the offset because in this specific scenario I don't want to just continue reducing the offset. I just want to count now because I can resolve these two. And then I'm where I started again, and I set it again. Last one was a backslash, offset, and then I count here. I'm not sure if that covers all the cases, but let's give it a go. I just need to map line dot length to R, and then I have to map this, and then this can be a result. Get a sum of that. I mean, I should print it probably. Let's see about this one. Not right, too high. Let's check the example again. Maybe my calculation summing is wrong. 12. Yeah, 23 minus 11 is 12. That's good. So there must be some kind of edge case that I still, I'm missing. Let's look again here. A lot of wacky stuff here. confident about my double backslashes. /x should also work. Let's try this one. One, two, three, four, five. 5. That works. Let's try something with quotes, maybe. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I get 9. 1, 2, 3, 4, 6, 7. 1, 2, 3, 4. Yeah, 9, 9, 9. It should be 9. That's fine. I have no idea what it could be then. Maybe this. 1, 2, 5, 6, 7, 6. Aha. I only get 5. That's weird. Why? 1, 2, 3, 4, 5. And I was saying I'm so confident about my double backslashes. This one's a backslash. Backslash is true. Offset to 1. Then I don't set offset. So I should count it then. It's not a backslash. There's something else that's wrong, or Let's throw on this debugger here. Okay, we have this string. Characters N, Y, W, B, V. This point result is 5. I have offset, I do -1. Offset is 1. Aha. Strange, let's try again. We have this character here, backslash, backslash. We check line +1, what is it? This must be backslash, backslash, yes. So we go there, right? We go here. If backslash, why is this one true? Well, no, it makes sense. It was false all the way at the beginning. Now it sets to true. Okay, then we decrease the offset. Okay, then we go back and we have the 7th. I equals 7. We go here. Now last one was backslash is false. We go line +1 is okay. Okay. Yeah, that's wrong. We always go into this loop here, checking the next character, but we only want to do that if if last one was backslash. This here applies to these guys. Let's try this. Now we get 6. Okay, let's try the full thing. And we're a little bit lower, which is probably right. Yes, let's go. Okay, that was the issue. So we were when we see the second backslash, we only care about it if the last one was backslash. Otherwise we have to treat it like a first backslash. Well, basically we only want to go into this here when it's a first backslash. If it's a second backslash, we don't want to check the next character to decide something. We just treat it as a character then, so we can count it. Okay, what's the variation? Now let's go the other way. In addition to finding the number of characters of code, you should now encode each code representation as a new string. Find the number of characters of the new encoded representation, including the surrounding double quotes. Quote, quote, in quotes 2, quote, backslash code, backslash code, quote, increase 2 to 6. Your task is to find the total number of characters representing newly encoded strings minus the number of characters of code in each original string literal. For example, for the string above, the total encoded length, 42, minus the characters in the original code representation, 23, just like in the first part. Alright, let's get back into this. I took a quick break. What we need to do now is replace or encode each code representation as a new string. This turns into this. This turns into this. Okay. So basically, what I'm thinking is we need to go through each character and just replace quotes with backslash quote and then wrap it with quotes again. Here we do the same. Here we have backslash quote in the middle, so what we do is we just replace backslash with double backslash and quote with backslash quote. Here, yeah, quote with backslash quote, backslash with backslash, backslash x27 stays, and so on. Your task is to find the total number of characters to represent the newly encoded strings, minus the number of characters of code in each original string. So that stays the same, but so we take this line length, or that's the original one, line length, oh, here we did 23 minus 11, and now we do 42 minus 23. So we want to have line length here and R here, and then instead of line we have modified line is line replace, and just replace string with backslash string, something like this. 1, 2, 3, 4. 1, 2, 3, 4. Line, line, modified, line, line. No, modified line. Let's see what happens now. Actually, it would be more interesting to have our examples here to verify those, to see if the modified string is correct, and then we can see. Okay, here we have loads of backslashes. Now that looks wrong. This here. Ah yeah, one thing I mentioned and then I didn't do it is I wanted to wrap the string with quotes. Okay, let's see. So we have quote, backslash quote, backslash quote, quote. Yes. ABC is ABC with this construction around it. That's good. Here we have a gigantic amount of backslashes, which is too much. What we want is one backslash to turn into two backslashes. But if we turn one backslash into two backslashes, and then we turn two backslashes into four backslashes, then we end up with this. Would it work if I first replace two backslashes with four? Now I have three backslashes and a quote. It works for this case. And here it also looks good. Backslash quote, backslash, backslash x. Let's just try it. Modified line. Don't think we use line that often. And then we can have a look. What happens here? Coded length is 6. But this guy. Do we have that? Memory size 2. modified line is this. What happens? Is there something I have to change about our algorithm? No. Why would it? Oh, maybe it just wants the length. Total number of characters? Do we just want the length? Okay, so we don't even need our algorithm here, which is kind of strange, but okay. Let's try the real one. See if we're good, and we're good. So that was more simple than expected in part 2. Just apply this transformation and count the lengths and subtract them. So that's it for today. See you tomorrow. Bye.